Okay, friends, in this one I'm going to show you how to do a sketch of a transformed exponential function. So take a look here. I have, for example, y is equal to 3 to the x minus 2 and then minus 4. So that's our function right there. Let's write down some key pieces of information about it. So first of all, this number, the negative 4, that becomes the horizontal asymptote. You've got to know that, okay? It's a shift of 4 straight down, in other words, right? So this is down 4 this way. And then this quantity right here, so let me do this one in pink, the 2 here, right? The 2 by itself, that means a shift of 2 units to the right. So the parent graph is basically y is equal to 3 to the x. And then this one is a transformed version. That looks like this, the horizontal asymptote. Okay, so that's equal here to negative 4. That's y equals negative 4. And then the horizontal, I'm going to call it the hs, the horizontal shift, that's equal here to positive 2. So you take y equals 3 to the x, you shift it down by 4, and you add 2 to each x coordinate. That's the general idea. So let's look at a graph here. So it looks like this and like this, basic set of axes. So x and y. All right, same thing here, same thing here. All right, now take your basic 3 to the x curve. Let me show you a couple points on it that's useful. So 3 to the x, for example, using y equals 3 to the x, I have when x is 0, we have 3 to the 0, which is 1. So that gives us the point, in other words. That gives us a point. The point is 0, comma 1. And then let's say when x is 1, then we have the point 3 to the first, which is 3. So in other words, we have the point 1, comma 3. So those are our points. So let's mark a picture here representing the basic 3 to the x. So this is 1 point and then 1, comma 3. So 1, 2, 3 is up here about. This is another point. Okay, so the basic 3 to the x looks like this. Okay, and notice that here the graph gets closer to the x-axis, but it doesn't cross it. So that's telling us that basically over here there's always a gap, right? Like there's a gap. There's a gap between the graph and the positive, the negative x-axis in this case. Keep that in mind. So now, remember we have these points. So 0, 1, that's this point here. And then also this other point, 1, comma 3, so that's this point right here. Now we're going to transform them according to this. So the y you're going to decrease by 4 and x you're going to increase by 2. So let's carry this out on the side here. So we know what the new points are. So I'm going to take the point 0, 1. Okay, and what I'm going to do is I'm going to do this as a transformation according to the prescription. Add 2 to the x, so it's going to be 0 plus 2. And the negative 4 means subtract 4 from y, so it's going to be 1 minus 4. So that means, let me fix this. So that means that the new point will be the point 2, comma, negative 3. Take the other point there, 1, comma, 3. And according to the prescription and the formula, you're going to do 1 plus 2, and then let's see, what else? 3 minus 4. That's going to give us the new point 3, comma, negative 1. Now we know what our new points are. We got to incorporate them into the graph so we can pin it down a little better than just, the overall shape. So this point, you're going to go 2 to the right. So this was 1 about, so it's going to take you to about here, and it's going to go 3 down. So let's see, 1, 2, 3, that's about here. Okay, so that point, I'm going to call this point A. Then point A prime is this point. That's the image of it, okay? Another point 1, comma 3. So let me label 1, 2. Let's see. So this is negative 1, negative 2, negative 3 this way. Right, so it's 2, comma, negative 3. The other point is going to be now 3, comma, negative 1. So that's about here. 3, comma, negative 1. So let's call this B. So this is going to be B prime. That's the new point, B prime. And on this graph here in yellow, remember, right, what I'm doing in yellow here, that represents the horizontal asymptote, okay? Well, the horizontal asymptote also goes straight down by 4 units. So it's going to go down by 4. Right now, as you can see, it's the x-axis. It's like saying y is equal to 0. So 0 minus 4 is negative 4, which means it goes down to about here. This is, now the horizontal asymptote is this line right here. See this? Like this. And then the graph, the overall shape doesn't really change much, so you're going to basically do something like this. You're going to go through these points and then go like this pretty much. You see this? And then again, notice that here, right, the gap is still there right here, okay? Whatever gap you have here, that gap is still present in this position between the graph and the horizontal asymptote. So this is y is equal to negative 4. And now this graph right here, right, that's equal to 3 to the x minus 2 minus 4. And those are our points, the transformed points. Don't forget those. So this would be 2 comma negative 3, all right? And then this point here with specific coordinates, 3 comma negative 1. That's an example in great detail of how to take an exponential function like 3 to the x or 2 to the x. It doesn't really matter. 5 to the x, and then apply a transformation. So choose a couple points, transform those, transform the horizontal asymptote also, and then mark up that new information, and you have your graph. Thank you. Please leave a like, please subscribe, please leave some comments. I read them for feedback. I will see you in the next video.